Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaro. Students, in this session we are going to discuss the MCQs on topic heat. Very important topic. Don't skip the video. Let us start the session. Okay. Yes. Coming to the first question. SI unit of heat is dash. What is the SI unit of heat? You know very well, heat is nothing but energy. Heat is nothing but energy. So energy units are joules na. So SI unit is considered as joule. Okay, if they are asking CGS unit, then that is the calorie. Calorie. Okay, so here answer is option A, joules. We know very well what is the unit of power. Newton is the unit of force. Ohm is the unit of resistance. Okay. Now coming to the next question. The relationship between joule and calorie. Relation between joule and calorie. You know very well calorie is the bigger unit. Calorie is big unit than the joule. Okay, so 1 calorie is equal to 4.2 joules or approximately 4.18 joules. So if you want joules, 1 joule is equal to 1 by 4.18 or 4.2, that is approximately 0.24 calorie. 0.24 calorie. So the answer is option A. Answer is option A. That means calorie is like a 2000 rupees note. Okay. Joule is like a 500 rupees note. 1 calorie, 2000 rupees note is equal to 500 notes. Correct. So in the same way, 1 calorie is equal to approximately 4.2 joules. 1 joule is equal to 1 by 4.2, that is approximately 0.24. Coming to the next question, what is the CGS unit of heat? Just now I have given what is the CGS unit of heat, that is calorie. That is the calorie. Okay. Now coming to the next question, find the required heat energy to rise the temperature of 1 gram of water through 1 degree. That is nothing but definition of the calorie. That is nothing but definition of the calorie. So the answer is option D. Which determines the direction of flow of heat? Which determines the direction of flow heat? So whenever the heat flow takes place, whenever there is a temperature difference, then only heat will be flow. Correct? So which determines the direction of flow of heat? That is nothing but temperature. Temperature determines the direction of flow of heat. Okay. Coming to the next question. Consider you contact two bodies A, B, but after that you observe that there is no flow of heat between the two bodies. From these incidents, you can say that dash. For example, if the body A is at 50 degrees, if the body B is at 30 degrees centigrade. Okay, whenever those two are in the contact, then what will happen? This A loses the heat, or heat transfer takes place from 50 to 30. Okay, from 50 to 30. So it is whenever the 50 is going to be lost, it is if it is going to be approximately 35, and it is also some gain somewhat of it is also going to be approximately 35. Then what will happen? Both are at the same temperature. Then heat flow takes place? No. Then no heat flow takes place. That means whenever the temperature of the bodies are same, then there is no heat flow. So here they have given no flow of heat that possible whenever the temperature of A is equal to temperature of B. So that is two bodies have the same temperature. Okay. For example, let us take in a one room. Room temperature, let us consider 27 degrees centigrade. If you place any one object A, let us take room is the object B. If it is, let us take 100 degrees Celsius. Okay, for example, you place water of 90 degrees Celsius. Okay, in the room, then what will happen? It loses the heat from 90 to 80 and then 70. After some time, if you see that one, that is 50. From like that, it is going to be become 27 degrees centigrade. So whenever your water temperature is going to be 27 degrees centigrade, then after that it may not lose any heat. Correct or not? If you place some hot water into your room temperature, after some time it also gets the room temperature. So that means whenever the two bodies are having same temperature, then there is no flow of heat. Whenever there is a temperature difference, then only heat flow takes place. Okay. What is the freezing point of water as per Fahrenheit scale? So freezing point in case of Fahrenheit scale, that is 32 degree Fahrenheit. In case of Celsius, in case of Fahrenheit, in case of Kelvin. These three are very important now. Freezing point or ice point, boiling point or steam point. Freezing point of water at 0 degrees Celsius. Fahrenheit 32 degree Fahrenheit. Kelvin 273 Kelvin. Okay. So boiling point 100 degrees Celsius. 212 Fahrenheit. And here 373 Kelvin. Okay. So these points are very important. Answer is option B. Coming to the next question. Normal room temperature in degrees and kelvins respectively. We know normal room temperature is approximately 27 degrees Celsius. If you want in the Kelvin, Kelvin is equal to degree Celsius plus 273. That is 27 plus 273. That is 300 Kelvin. Okay, 300 Kelvin. So 27 and 300. Coming to the next question. Normal body temperature in degrees, Fahrenheit and kelvins respectively. So we know very well our normal body temperature, that is we know very well in the Fahrenheit 98.6 Fahrenheit is said to be a normal body temperature. So if more than 98.6, we can say we have fever. Correct? We know this one very well. If they are asking in the degrees, so you can convert it into a degree Celsius. How you can convert? We have C by 5 is equal to F minus 32 by 9 is equal to we have, that is K minus 273 by 5. So this is the relationship we have now. So from these two we can convert and we can get degree Celsius as 37. And if you know degree Celsius, Kelvin is very easy. Degree Celsius plus 273, that is equal to, we can say 310 Kelvin. So the answer is option A. Okay. So 98.6, 37 and 310. Okay. So we have to remember this relation. It is very important. Okay. In the theory session, I have given in detail about this. If you want, you can watch that one available in the playlist. Okay. The scale of clinical thermometer is marked from dash to dash. So normal body temperature is nothing but 98.6. So we can go with from 96 to 110 degrees. Okay. So the answer is option A. Coming to the next one. The lowest possible temperature is dash. What is the lowest possible temperature? So temperature SI unit. If you can consider temperature SI unit. What is the temperature SI unit? That is Kelvin. Kelvin is considered as very important unit, that is SI unit of the temperature. Okay. So the maximum possible lowest possible temperature in the Kelvin is 0 Kelvin. This is the lowest possible temperature is nothing but, you can say 0 Kelvin. Okay. at this lowest possible temperature, the kinetic energy of the molecule is 0. Okay, kinetic energy of molecule is 0. So can also called the temperature at which molecular motion is ceases. Molecular motion is ceases is nothing but lowest possible temperature. It is also called as absolute temperature. Absolute temperature or absolute zero temperature. Okay, so that is 0 Kelvin. 0 Kelvin in the sense, if you convert into degree Celsius is equal to Kelvin minus 273. That is 0 minus 273 degrees Celsius. That is minus 273 degrees Celsius. Okay, so this is the lowest possible temperature in degrees Celsius. Lowest possible. Okay, so minus 273 degree Celsius. Okay, so here you have to make answer in the Celsius. Okay, all of you clear? Lowest possible temperature is nothing but 0 Kelvin. 0 Kelvin in the sense minus 273 degrees Celsius. That is also called as absolute zero temperature. The temperature at which molecular motion is ceases. The temperature at which kinetic energy of the molecules is 0. Okay, very important. At which temperature molecular motion ceases? Just now I have given at 0 Kelvin or minus 273 degrees Celsius. Okay, 0 Kelvin. So the answer is option 0. So if it is the lowest possible temperature, means there is no negative temperature in Kelvin scale. That is also very important. 0 is the lowest, means there is no chance of negative temperature values in the Kelvin scale. Okay. Is there any negative temperature is possible in the Kelvin scale? No. No. Lowest possible in Kelvin is 0 Kelvin only. So there is no negative temperature is possible. Which when the ice is heated from 0 to 10 degree, then the volume of the water is dashed. I have explained this one in detail. Water has anomalous behavior. We know whenever at 0 degrees Celsius, it is in the form of ice. Ice. Whenever it is in the form of ice, means it has high value, correct? Its value means somewhat of higher. Whenever if you heat this one, the water will be, the ice becomes water at 4 degrees Celsius. Okay, we know water have less value. For the same amount of ice, if it is melted, it becomes water that occupies somewhat of less value. Okay, you can observe this one. If you take some ice and place in the room temperature, after some time it will be melted. Okay, and it occupies somewhat of less space. And we know very well, whenever we heat anything, that means solids, liquids or gaseous, then what will happen? Its volume increases, it expands. Okay, so from 4 degrees centigrade to 10 degrees centigrade, as we increase the temperature, then it will be expands. Expands means volume is increases. So what is happening? First of all, higher to lower, that means decreases, and then lower to higher increases. So first decreases and then going to be increases. Okay, and if you go with the density, mass by volume, here volume is less means density is more. So at 4 degrees centigrade, we can say maximum density. Very important. Maximum density of water at what temperature? At 4 degrees Celsius. Okay, all of you clear? From 0 to 10, 0 to 4 decreases and then increases. 0 to 4 decreases, and then 4 to 10 increases. Okay. Coming to the next one, which of the following represents the absolute zero temperature? Absolute zero temperature is nothing but 0 Kelvin. 0 Kelvin in the sense minus 273 degrees Celsius. So the answer is option C. Answer is option C. Coming to the next one, what would be thermal resistance of ideal conductor? Ideal conductor means perfect conductors. Okay, so if you give some amount of heat, 100 joules of the heat at one end, and it transfer the same 100 joules of heat toward the another end. So there is no loss. No loss. No loss means no opposition. No opposition means no resistance. No resistance means zero resistance. Whenever there is no opposition or zero resistance, whatever the heat you are sending, you are getting same heat at the receiving end. Okay. Coming to the next question. The dash of a body is the amount of heat required to raise the temperature by 1 Kelvin is dash. To raise the temperature by 1 Kelvin is dash. That is nothing but heat by temperature. Heat by temperature. That is nothing but heat capacity. Heat capacity. Units are heat, joule. Temperature Kelvin, joule per Kelvin. So the answer is option C. Answer is option C. Okay. Coming to the next question. Why does the bottom of lake not freeze in a severe winter even the surface is frozen? Why? Because the conductivity of ice is very low. The conductivity of ice is very low. So that means it may not allows the heat or cool through it. Okay, so then what is happening at the bottom? It is going to be freeze. Okay, and that cooling may not goes effectively to the bottom of the water. So here we have the water now. It may not effectively goes through the ice. Okay, then that's why this water may not be freeze because of the conductivity of ice is very low. If the conductivity is more, then total will be become ice. Specific heat is dash. What is the specific heat definition? Very important. Specific heat is nothing but it is the energy needed to increase the temperature of 1 gram of substance by 1 degree Celsius. Increase the temperature of 1 gram of substance by 1 degree Celsius. Okay. The relationship between coefficient of linear, superficial and volume expansion. Linear expansion only in the dimension length will be increased. Superficial area only length. Here area, that means both length and breadth. Volume area into height, that is length, breadth, height, 3 dimensions. So here what is the ratio we have? Here only length increases 1 dimension, here 2 dimension, that is 2 times, here 3, that is 3 times. So the ratio is 1:2:3. 1:2:3. Coming to the next question. If the temperature of water increases from 0 to 4, 0 means ice form. Ice means higher the value, it occupies more value. 4 means it is becomes water. Water, whenever the ice melts into the water, its volume somewhat of reduces. So higher to lower, that is decreases. Okay, decreases. From 4 to 10, increases. Coming to the next question. The mode of heat transfer in the solids, direct heating. Direct contact of heat. Okay, we can heat the solids directly. And in case of liquids, indirect heating, we may not heat the liquids directly. Now we have to take that liquid into the any vessel and then we have to heat that one. Okay, so that means heat will be transferred by molecule to molecule. So liquids, molecule to molecule, that is nothing but convection, indirect. Here radiation without contact, it is the fastest mode of transfer. It is the slowest mode of transfer. Okay, so radiation, we can receive the heat energy from the sun if we have a lot of distance. Okay, approximately 15 crore kilometers. Okay, we have the distance. Still, we are getting the heat through the radiation process. So it is the mode of heat transfer is very fastest. Here, if you place any object in outside in summer, it heated from every direction through the radiation process. In liquids, convection. Which is the fastest mode? Which is the fastest mode? Radiation method is the fastest mode. The following, which is the slowest mode? Conduction is the slowest mode. Okay. Cooking pot is coated black because why? Because the black substances are absorb more heat. These are absorb more heat. So that's why you can observe in the summer if you wear really dark color shirt or pant, whatever it may be, then we receive the we feel very hot, very hot. So you can observe this one in the summer. Okay. So black substances absorb more heat. At what temperature Celsius and Fahrenheit are equal? So what is the relation between Celsius and Fahrenheit? C by 5 is equal to F minus 32 by 9. Celsius and Fahrenheit are equal. So we have to make C is equal to F is equal to at any one value. Let us take X, then C plus X, F plus also X. Now we can say both are equal. So if you multiply this, cross multiply, 9x is equal to 5x minus 32 into 5, 160. Na? So you will get 4x is equal to minus 160, that is x is equal to minus 40. So at minus 40 both will becomes equal. At minus 40 both will becomes equal. Okay, coming to the next one, the change of state directly from solid to gas. Solid to gas is with the name of sublimation. Sublimation. Okay, for example you can say camphor. Camphor is in the solid. If you heat this one, then it is directly enter into the gas without forming of liquid. Without forming of liquid. And you can say this is the sublimation process. Sublimation process. Okay. Here we have so many states of heat, solid, liquid, gas. If you heat the solid, solid, let us take the solid is in the sense take as ice. If you heat, then what will happen? Ice will becomes water. Okay, so we can see that process as fusion. Fusion is the process. If you heat, then solid becomes liquid, and if you heat the liquid again, then you will get the gas, that is vapor, steam. Okay, that process is called as vaporization. Vaporization. Okay, and if you cool the gas, then you will get liquid. That process is called as liquidation. Okay, and if you cool the liquidation, or we can also consider as condensation. Condensation. If you cool the if you cool the gas, it will becomes liquid. Okay, and there is a two direct methods: solid to gas directly. solid to gas is directly sublimation. Example camphor. Gas to solid, deposition. Deposition. Okay, let us take CO2. CO2 gas directly enter into the solid CO2, that is dry ice. That is dry ice. Okay, so those are the examples. So solid to liquid, fusion. Liquid to gas, vapor, that is vaporization. Gas to liquid, cool, that is condensation. Liquid to solid, solidification. Okay, and solid to gas, sublimation. Gas to solid, deposition. Okay, the change of state directly from gas to solid, reverse, that is deposition. That is deposition. Okay, the hot objects heat to its surroundings in the form of heat radiation. The rate of loss of heat depends upon Newton's law of cooling, that is nothing but temperature difference between the object and its surroundings. Whenever there is a lot of temperature difference, then rate of heat loss will be higher. So it depends on temperature difference. Temperature difference. SI unit of temperature, Kelvin. Okay, coming to the next one, Kelvin scale divided into equal parts. Kelvin starts from 273 Kelvin to 373 Kelvin. So how many equal parts? 100 equal parts. So the answer is option B. The heat stored in water vapor. Whenever if you take some water and if you heat that water, it becomes into vapor, correct? More than 100 degrees Celsius. Then whenever if you touch that vapor, then you feel hot, very, very hot, correct? So that heat stored in the vapor is heat stored in vapor is called as latent heat. Latent heat. So the answer is option C. Okay. Heat is measured by generally calorimeter. Okay, heat units are calories, so calorimeter. Thermometer, that is measured temperature. Okay, not heat. Not heat. Pyrometer, very high temperatures. Very high temperatures. Curie point is the temperature at which Curie point is nothing but if you take any one ferromagnetic material, if you heat that ferromagnetic material, at certain point it loses its magnetic properties. It loses its magnetic properties and becomes para. Okay, so that temperature is nothing but we can say Curie point. So that is metal losses magnetic properties. Losses magnetic properties. Air is expand when it is dashed. So we know very well whenever we heat the solids, liquids or gases, then those will be expands. Okay. And physical quantity entropy. Entropy is nothing but you can say heat by temperature. Heat in the sense joule, temperature Kelvin. So joule per Kelvin. So the answer is option D. Okay, heat capacity also same formula, same units. Instrument for measuring low temperature. Low temperatures, cryometer. Okay, those are, you can also say that cryogenic temperatures, those are measured by cryometer. Pyrometer, high temperature. Bolometer used to measure the electromagnetic radiation. Barometer used to measure the pressure. Okay, pressure of the atmosphere. Density of water is maximum at dash 4 degrees Celsius. I have already explained. At this volume is low, so density is more. Density is equal to mass by volume, inversely proportional. Heat capacity, joule per Kelvin, just now I have given. Coming to the next question. The questions are completed. Okay, we will take next topic in the next session. And students, if you want to download the PDF, you can visit sunnilengineeringacademy.com. I have given the link in the description box. You can download from that. Okay. Okay, students, if you like my classes, don't forget to click on like option. Try to click on like option, and also please share the session to all your friends. Okay. Thank you so much, guys.